Hi, my name is Jason Tran, and I will be demonstrating my smart car. I use a state machine to implement the car logic. It's a little messy, but here we go. Here, I have a TM4C123 launchpad, a car driven with two stepper motors beneath the chassis, uh, driving the wheels, a battery pack that gets limited to a 5-volt output due to the voltage regulator, which this runs the battery pack, and a IR avoidance sensor, which is placed at a slight angle because I couldn't place it at a 90-degree angle. I'll run through the port connections really quick. PF1 is used for the input for the IR sensor, PF0 for the reverse, PF4 for the forward buttons, forward button, PB033 for the left stepper motor, and PB4 through PB7 for the right stepper motor. Three inputs are implemented for the car. The raise button, which is our onboard button that's connected to port PF4, and stage button, which is connected to PF0 as mentioned earlier. The IR sensor is pointed at a slight angle because I couldn't place the breadboard at a 90-degree angle, but should still do the job for this demonstration purpose. As far as the logic, I have 6 different states. Wait, step 1, step 2, step 4, and stop. This is my state diagram for the more FSM and my state table for the more FSM. Um, the three inputs that we assumed are move, forward, and reverse. For move, if 0, no state transitions will happen. If move is 1 and forward or reverse are 1, but not both, then the car moves in the expected direction. Move is set to 1 if the requested number of steps is not reached, or 0 if it is reached. For forward, if forward is 1 and move is 1 and reverse is 0, then the car moves in the forward direction, otherwise the car does not move. For reverse, if reverse is 1 and move is 1 and forward is 0, then the car moves in the reverse direction, otherwise the car does not move. The sensor is mounted into the vehicle facing forward, which should detect an object about 2 to 3 inches in front of the car. In race mode, the car will drive about 36 inches forward, and in stage, the car will drive back 1 to 3 inches. If it ever detects something in front of the vehicle starts moving. I am using port B to drive all my stepper motors. As far as the code, which I will pull up right now. As far as the code, each if-else statement determines the numbers of steps remaining in order to follow the instruction given. For example, switch 1 right here is set to move forward, and thus it requires 9,000 steps in order to cause it to move 36 inches respectively. The Sysdig cannoli just checks whether it is greater than 0 and continuously iterates until the condition is met. I'll stop and cause the car to stop moving. Now I'll be demonstrating the car moving. Just to test the IR sensor, approximately 2 to 3 inches in front of the IR sensor, the light will turn green. Okay, I'll press a button. This would be going in race mode, moving approximately 36 inches forward. Here I'll be demonstrating the car moving approximately 36 inches. And now couple inches backwards. And if it goes forward again and it detects movement, then it should immediately stop. Another again. By putting my hand in front of the sensor, it will cause the car to stop moving, which is implemented in our state machine that I will show right now. It will cause it to go to stop, and once it goes to stop, it will cause the car to go back to the initial state, which is wait.